right, stats, I'm going to give you the notes for section 9.1. There are really kind of two problems. Example 1 is the main one using the main formula that we have here for calculating stuff. But then we have the p-value method and critical value method. So I'm going to show you those two methods. And then on example 2, we're doing a confidence interval. Okay, so like exactly what we did in chapter 8, but we're doing it for 2 proportions rather than just 1. Okay, so we'll look through what all that stuff is. Yesterday, you guys wrote down these formulas down here. I'm going to erase some of this stuff. But this is going to be the formula, the main formula that we're going to use for the front side at least. And then we're going to do p-value and critical value method. On the homework, we're going to do all of them. There's only 5 problems. Number 1 is just asking for you to tell what N1 is, tell what P hat 1 is, tell what Q hat 1 is. Okay, tell what N2 is, tell what Q hat 2 is, or P hat 2, whatever. They're having you fill out all of these things and just writing in those variables. Okay, that's all you're needing to do. Number 2, I want you to do the critical value method. 3, do the p-value method, and then the back 2 do the confidence interval method for each one of those, okay? And then they have some questions, so make sure you're answering those questions, okay? Test the claim by constructing the confidence interval. Test the claim by constructing the confidence interval. Based on these results, does it appear that men and women have equal success? Okay, we'll answer those questions as we go along. So do confidence interval for 4 and 5, critical value, p-value for 2 and 3, okay? All right, let's start with this example. We've got this formula going on up here. All of the 1s refer to your sample 1. All of the 2s refer to your sample 2. And then the one thing that I will change here is that we will always list our null hypothesis as the p's are equal to each other. Normally our hypotheses would be, I guess I wrote it up here. Normally we would have our hypotheses like p be equal to some number, right? And p not equal to some number. Now in chapter 9, we're saying the first p is equal to the second p and the first p is not equal to the second p. Now, if the first p is equal to the second p, so the 2 p's are equal to each other, and I were to subtract the 2 p's, this value should be 0. So you can kind of basically ignore this top part of your equation when you're finding your test value z, okay? So we'll go through and we'll do that, all right? Here we go, example 1. They are saying rear license plates. So the fraction of the population, the proportion of the population that has rear license plates only. Connecticut, we have sampled 2,000 vehicles, and of those 2,000 vehicles, 239 had rear license plates only. That means no front license plate, because evidently in Connecticut, you don't have to have a rear license plate, or you don't have to have a front license plate, whatever. So 11 or almost 12% of them have rear license plates only. In New York, only 2% or 1.6% has rear license plates only. So we're trying to say, are those 2 percentages the same as each other, right? Do you think 12%, almost 12% is the same thing as almost 2%? I don't know. I don't really think so. But we're going to say for our null hypothesis that they are equal to each other, okay? We're going to say that they're equal, all right? Blah, 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 blah. Let me fix the P. P2. There we go. Use a fish value of 0.05, that's 5%, to test the claim that Connecticut and New York have the same proportion. Okay, so they don't say that one is greater than the other, so we're just going to say our alternative hypothesis is not equal to. So just like last time, we would have 2 tails if that's the case. And this fish value of 5% would have to be split in half. So I would have 2.5% and 2.5%. Okay. All right. So 4, I'm going to go p-value method down here. P-value method on this bell curve. Here would be 0%. Here would be 100%. My cutoff marks here and here, where the dark is, right? I don't know if you guys can see, I'm trying to relate this up to here, right? This would be 2.5%, and this would be 97.5% are my cutoff marks, okay? Versus the critical value method, 0 lives here for a z-score, and then if this is 2.5% and this is 2.5%, I have 95% in the middle, okay? If you look up on your positive chart, 95% is 1.96, so my cutoff mark here for the dark region would be negative 1.96, and here for the dark region would be positive 1.96. And we're going to try to figure out where he lives. Okay? There you go. He's ready to go. All right. Here we go. Test. My test statistic or my test value. We have to do all these calculations right here. So the very first thing is that I want to do p hat 1 minus p hat 2. Okay, p hat 1 is that percentage. So 0.117 minus 0.016 all over. Now, I get to ignore this part because that's going to end up being 0, right? All over the square root of, and this is going to be the ugly part, okay? I want to know what P bar is and Q bar is and N1 is, okay? So I know N1, I know N1 is 2049, so 2049, and I know N2 is 550, right? Because we use those to find my P hat 1. Like I think it was up here. P hat 1 was X1 divided by N1. This is your X1 and this is your N1. And this is your X2 and this is your N2. Okay, so that's how that works out. All right. Then I have to find P bar. Okay, P bar is X1 plus X2 divided by N1 plus N2. So I'm literally just going to take 239 plus 9. And I'm going to add those together and I'm going to divide by 2049 plus 550. Okay. All right. Give me a moment to do that. 239 plus 9. And you don't get to complain because I am on a phone calculator. I already told my calc kids that when I recorded their video. You guys are not allowed to complain because I'm on a stupid phone calculator. And I have to enter everything in like 40 bajillion times because it doesn't do it right. Okay, 25.99. So 248 divided by 25.99. All right, P bar is going to be 0.095. There you go. So 0.095 times Q bar, which will be, I don't know, 0.905. Okay, so I got 0.095 times 0.905. Oh my heavens. Okay. All right, here we go. I'm going to do pieces. This top piece is going to be 0.101. That's that top number. If I subtract those two, 0.101. Okay. Then I have the square root of, I'm going to do this chunk right here. And that is 0.095 times 0.905 divided by 2049. Oh my heavens. 0.00042, let's say, plus. Okay. 0.095. This is the cumbersome part. You got to have some patience. Times 0.905. That's why we're big kids, right? Divided by 550 is 0.00016, let's say. All right, I'm going to add those together. 0.00042. And I'm going to take the square root of that. Okay, so I have 0.101 divided by 0.014. Okay. All right. So, yeah. 0.101. 101. So you can't complain because I'm literally doing this on a phone. Okay. All right. Finally, 7.21-ish is what I'm going to have for my test value. All right. Now we just have to come up with a conclusion. Okay, hold on. To test the claim that Connecticut and New York have the same proportion. So my claim is going to go at the top, that they are the same, that they are equal to each other. I don't think these numbers are equal to each other. And you can probably figure out if my test value is 7.21, the critical value method, if I look down here, critical value method 1.96 is my cutoff. 7.21 is like all the way over here. Okay, so are we going to say that they are equal or are we going to say that they are not equal? We're going to say this, right? They are not equal to each other. If they were equal to each other, they'd be in this land. Okay, they are not equal to each other. So using the critical value method, he is all the way off to the side over here. Now, using the p-value method, 7.21, if you look up on your chart, the p-value. So you would look up like 7.2 and then you'd go over here to 0, 1, right? And like it doesn't go, like 3.5 is as far down as it goes. And it says anything 3.5 and up is 0.9999, which is 99.99%. Okay, so this guy has a p-value of 99.99%, which means that if you look on the p-value chart right here, we are all the way over here as well, over like all the way almost close to 100%, okay, which gives us the same results. So regardless, we're going to say that, I'm going to say proportions for Connecticut and New York are not the same. They do not have the same frequency of rear license plates only, right? Connecticut has way more, okay, because, you know, like our results were all the way out here. So same hypothesis testing as we were doing before, but really, really icky equation for it. Yuck, yuck, yuck. Okay, that's where the cumbersome part comes into play. Okay, so you've got one p-value method, one critical value method, and then we go to confidence interval method, which is like this, okay? All right. When we did confidence interval method in chapter 8, P lived in the middle, and we would take P hat, and we would subtract the error, and we would have P hat, and we would add the error, okay? Now, here we have two P hats. So what we're going to do is, instead of doing just P hat, we have P hat 1 minus P hat 2 minus the error, and then P hat 1 minus P hat 2 plus the error, okay? So that's how that works. And then the error is calculated by this big, long, ugly thing, okay? All right, so let's go to this, and we're constructing a 95% confidence interval because our fish value is 5% that we split in half, so we had 95% in the middle, just like they have here, okay? And they want us just to do all these calculations, all right? So first thing I'm going to do is I'm going to do the error, okay? The z value is the z value for 95%. That's on the chart. We used 1.96 on the other side. It's the same thing here, 1.96. Okay, P hat 1 was the 0.117. No, that's not either. Yes, it is. Yes, it is. 0.117, I think. Yeah, 0.117. Okay, Q hat 1. Okay, and N1 was 2049, I think. Okay, 2049. Let me check that. 2049. Okay. P hat 2, I'm going to figure out what Q hat 1 is here in a second. P hat 2 was 0.016. Okay. What was that number? I just had it. 550. That's what it was. 550 was N2. Okay. And we're plugging these in. Q hat 1 is the opposite of P hat 1, right? So these two add up to be 100%. So that is like 0.883, I think. Let me check that real quick before I say true. Okay, 0.117 no, 0.117 subtracted from 1. 0.883, yes, true. Okay, 0.016 from 1 is 0.984. That is what Q hat 2 is, okay, from the equation. All right, now we just have to calculate this error. All right, I'm going to do it in pieces because I only have a phone calculator. So I've got the square root of this number plus this number. I'm going to figure out what these guys are. Okay, so I've got 0.117 times 0.883, enter, divided by 2049. And that is 0.0000. That's 4 zeros and a 5. Okay, we're going to go with that. All right, next one. 0.016. 0.984 divided by 550, and that is 4 zeros again, and a 2, and a 3 actually, is a 3. All right, I'm gonna add those two together. 0.00005 plus, I could have done that in my head. Why am I doing that? Whatever. Okay, 0.0008. That's what this is. Okay, the square root of that times 1.96. So the error is going to be 0.018, let's say, which is 1.8% error. Okay, 1.8% error. All right, what that means is that we're going to take our p hat 1 and subtract our p hat 2. So this is 0.117 minus 0.016. And if I subtract those, I get 0.101. Okay, 0.101 is like 10.1%. So I'm going to do 10.1%. I'm going to subtract from that my error, which is 1.8%. Okay, then I'm going to do 10.1%, and I'm going to add the 1.8%. Okay, so if I do that, P1 minus P2 has to live in here. Adding those two together will be, I don't know, 11.9%. If I add them, if I subtract, that is 8 point, I can't math right now. It is too late. It's too late for my brain. 10.1 minus 1.8 is 8.3%. Okay, that's my result. Now, how do we read that result? We know that H naught is that P1 is equal to P2, and we know that H1 is that P1 is not equal to P2. Okay, now we should get the same result up here, which is that they're like, we're going to cross off the top one, but here's how this works. All right, if P1 equals P2, then what is P1 minus P2? Like if I would subtract P2 over here, like P1 minus P2 should end up being 0. All right, so here's how we read this. Does 0 live between 8.3 and 11.9? No, that's why we're going to cross it off and we're going to circle this bottom one. So again, we're concluding that the rear license plates are not the same frequency in Connecticut and New York, okay? P1 minus P2 is always that 0 value, kind of like from the formula. So when you're reading this, all you're doing is saying, does 0 live between these two numbers right here? Every time. It's going to be 0 every single time, okay? And that's how you do the critical value or the confidence interval method, okay? You're going to do that for problems 4 and 5, okay? So get to working on those and then make sure you answer the questions as well. But that is what you should need. The hardest part is doing the dang formula. I mean, those are really ugly, but work together if you need to, come up with what the answer is, and you will be just fine, okay? All right, that's all I have.